Have you ever wished you could travel in time? It sounds like something straight out of a science fiction movie. But what if I told you that time travel is real, and it's happening all around us, all the time? And what if I told you that one of the most brilliant experiments to prove it involved nothing more than a few atomic clocks and a couple of commercial airplane flights? This is the incredible true story of the Haefel-Keating experiment, a journey that literally bent time and proved Einstein right in the most spectacular way. So let's rewind a bit. Back in the early 20th century, a young patent clerk named Albert Einstein turned the world of physics upside down. He proposed his theory of relativity, which included some truly mind-bending ideas. One of the wildest was that time isn't constant. It's not a universal clock ticking away at the same rate for everyone. Instead, time is relative. It can stretch and shrink depending on how fast you're moving and how strong the gravity is around you. Einstein predicted two key things. First, special relativity tells us that the faster you move through space, the slower you move through time. This is called time dilation. Imagine two twins. One stays on Earth, and the other blasts off in a super-fast spaceship. When the space-traveling twin returns, they will be younger than their sibling who stayed behind. Time literally passed more slowly for them. Second, general relativity says that gravity also affects time. The stronger the gravitational pull, the slower time flows. So, time ticks just a tiny bit slower for someone living at sea level compared to someone living on a mountaintop, because gravity is slightly stronger closer to the Earth's center. It sounds absurd, right? For decades, these were just theories, beautiful mathematical ideas with no concrete proof. Scientists believed Einstein, but they couldn't physically demonstrate it. The effects were just too small to measure with the technology of the time. Fast forward to 1971, technology had caught up. We now had something incredible: cesium atomic clocks. These aren't your average wall clocks. They are phenomenally accurate timekeeping devices. An atomic clock is so precise that it would only lose or gain a single second over millions of years. They work by measuring the incredibly stable and consistent vibrations of cesium atoms. With these ultra-precise clocks, scientists finally had a tool sensitive enough to measure the tiny, almost imperceptible distortions in time predicted by Einstein. Enter two American physicists, Joseph Haefel and Richard Keating. They came up with a brilliantly simple, yet audacious plan. If Einstein was right, they could measure time dilation by flying atomic clocks around the world. They would take a set of synchronized atomic clocks, leave some at their home base, the United States Naval Observatory in Washington, D.C., and take the others on a trip around the globe on commercial passenger jets. Their experiment had two parts. For the first leg, they would fly eastward in the same direction as the Earth's rotation. Flying eastward means your speed relative to the center of the Earth is your ground speed plus the speed of the Earth's rotation. This increased velocity should, according to special relativity, cause the clocks on the plane to tick slower than the clocks on the ground. For the second leg, they would fly westward against the Earth's rotation. This would decrease their overall speed relative to the Earth's center. According to the theory, this should make the westward flying clocks tick faster than the reference clocks on the ground. It was a perfect test. But wait, there's a twist. Remember Einstein's other theory, general relativity? That had to be factored in too. The airplanes would be flying at high altitudes, around 30,000 feet. Up there, the Earth's gravitational pull is slightly weaker than it is on the ground. According to general relativity, weaker gravity means time should speed up. So they had two competing effects. Special relativity's time dilation, caused by speed, would slow the clocks down. General relativity's gravitational effect, caused by altitude, would speed them up. The challenge was to see which effect would dominate and whether the final result would match Einstein's predictions. Before they even took off, Haefel and Keating calculated exactly what should happen. For the eastward journey, they predicted that the effective speed would be stronger than the effect of gravity. The clocks should come back having lost time specifically. They should be about 40 nanoseconds behind the clocks on the ground. A nanosecond is a billionth of a second. It's an unbelievably small amount of time, the time it takes light to travel about 1 foot. For the westward journey, the opposite was true. The gravitational effect of being at a high altitude was predicted to be stronger than the speed effect. So the clock should come back having gained time. They should be about 275 nanoseconds ahead of the clocks on the ground. With their predictions in hand, the experiment began in October 1971. Haffel and Keating, along with their precious cargo of 4 cesium atomic clocks, boarded regular, scheduled commercial flights. They literally bought tickets and sat with the other passengers, their billion-dollar experiment nestled carefully on the seats next to them. Can you imagine being on that flight? Just a regular trip, and next to you are 2 guys with a bunch of strange equipment that is about to prove one of the greatest scientific theories in history. They flew eastward first, a journey that took them around the world in about 65 hours. Then, after a break, they did it again, this time flying westward, which took about 80 hours. Throughout the flights, they meticulously monitored the clocks, dealing with power outages and the curious questions of flight crews and fellow passengers. When they returned to the Naval Observatory, the moment of truth arrived. They carefully compared the time on the traveling clocks with the time on the stationary reference clocks. The world of physics held its breath. The results were stunning. The eastward flying clocks had lost an average of 59 nanoseconds. The westward flying clocks had gained an average of 273 nanoseconds. These numbers were incredibly close to their predictions. The tiny discrepancies were well within the margin of error for the experiment. It was a resounding success. Haffel and Keating had done it. They had directly observed and measured time dilation. They had proven that a person who flies around the world literally ages at a different rate than someone who stays on the ground. In the case of the eastward flight, they returned a few billionths of a second younger than they would have been if they had stayed home. On the westward flight, they returned a tiny bit older. Time travel is real. Now, you might be thinking, a few nanoseconds? Who cares? Well, in our everyday lives, it doesn't make much of a difference. But in the world of technology, it's everything. Think about the GPS in your phone or car. The GPS system relies on a network of satellites orbiting the Earth. These satellites are moving very fast, about 14,000 kilometers per hour, and they are at a high altitude where gravity is weaker. Because of their high speed, special relativity predicts their onboard atomic clocks should slow down by about 7 microseconds per day compared to clocks on Earth. But because of their high altitude, general relativity predicts their clocks should speed up by about 45 microseconds per day. Combine the two, and the clocks on GPS satellites should run faster than ground clocks by about 38 microseconds every single day. If GPS engineers didn't account for these relativistic effects, the system would fail spectacularly. The positioning errors would accumulate at a rate of about 10 kilometers every day. Within minutes, your GPS would be telling you that you're in the next town over. The fact that GPS works at all is daily, constant proof of Einstein's theories of relativity. The Haffel-Keating experiment was the first to directly confirm this phenomenon that is now essential to our modern way of life. The story of Haffel and Keating is a beautiful example of the scientific method in action. It took a bold theory from a brilliant mind, the development of incredibly precise technology, and the clever, determined effort of 2 physicists to design an experiment that could test the very fabric of reality. It shows us that the universe is a much stranger and more wonderful place than we might imagine, where time itself can bend and warp. So the next time you're on an airplane, looking out the window at the clouds below, remember this story. You're not just traveling through space. You're also traveling through time in a way that's different from everyone on the ground. You are In a very real sense, a time traveler. The universe is full of secrets, and sometimes all it takes to unlock them is a little bit of curiosity, a few atomic clocks, and a round-the-world ticket. Thanks for joining me on this journey through space and time. If you found this as mind-blowing as I do, make sure to hit that like button and subscribe for more stories about the amazing universe we live in. See you in the next one.